Hey guys, my name is Neel and welcome to Neel Workshop Zone. So in this episode we're going to be talking about the topic linear equations in two variables. So in our previous episodes we talked about a lot of topics like probability, etc. So if you haven't checked it out, I recommend checking out those episodes. But in this episode we're going to be starting a new topic called linear equations in two variables. Now this episode will only just be an introduction so that we'll understand what are linear equations and what type of linear equations do we use in the upcoming episodes. So without further ado, let's talk about it. So first of all, what is a linear equation? So to understand that, we obviously need to understand what is an equation. So an equation is an algebraic expression which has an equals to symbol in it. So for example, if you write something random like 3x plus 2y plus z is equals to 0, this is an equation because it has an equals to symbol. That is kind of the main difference between an equation and an algebraic expression. We'll talk about that as we move on, but that is basically an equation, an algebraic expression which has an equals to. So now that we have understood what a simple equation is, now let's try to understand what is a linear equation. Now, a linear equation is an equation which only has the degree 1. So for example, here the degree for all of them are 1, right? But if it has another degree, like for example 3x squared plus 2y plus 2 is equal to 0, it changes into another equation like quadratic equation. So that is why the equation which do not have any powers and only has the power 1 or nothing, because we don't write power 1 to every variable, that is a linear equation. So now that we have understood what a linear equation is, now let's talk about a pair of linear equation. So a pair of linear equation is two linear equations in two variables which are together. We'll talk about them in the next episode. But the main thing that we have to discuss about in this episode is the linear equations itself, because linear equations, sorry about my handwriting, but linear equations are divided into two parts, which are linear equations in one variable and linear equations in two variables. Now linear equations in one variable over here has only one solution, whereas linear equations in two variables have infinite solutions. So for example, for a linear equation in one variable, we have to take something like 2x plus 3 is equal to 0, and since there is only one variable, it's called as linear equation in one variable. So that is linear equation in one variable. And on the other hand, linear equation in two variables I've just explained now, something like 2x plus 3y plus 7 equals to 0. So that is the difference between a linear equation in one variable and a linear equation in two variables. Now you might be thinking, what will be the type of sums that we'll have to encounter in the future? Well, the sums will be given as they'll be given two pair of linear equations, and we have to find out whether they are coincidental, parallel, or anything else. We'll talk about it in the next episode, but basically there is a system of linear equations. So linear equations, or the system of linear equations, has three parts, and the three parts are again divided in two parts. So let me just write it quickly. So the system of linear equations are divided. First, let's write two parts. The system of linear equations are divided into two parts. The first one is one which has no solutions at all, and the other one which has one or more than one solutions. So we'll talk about it in next episode because it includes stuff like parallel, coincidental lines, etc. So this is just a basic introduction to linear equations in two variables. It's a little bit of an easy chapter if you'll understand the main premise of it. So hope you enjoyed this video. If you did, don't forget to like, share, subscribe, hit the notification bell so you don't miss out any new videos. And that's all folks, and see you in the next one. Bye bye.